With winter setting in New Zealand and my visa only days away from expiring, I hopped on a plane and made my way back to the States. After a visit to Los Angeles and popping around the rest of the country to see friends and family, I eventually made my way to Maine to see Captain Noah Peffer and to visit one of America's most beautiful cruising grounds. Hello friends, we are in, is this called Brooklin, Maine?
Brooklyn.
We're in Brooklin, Maine. We've got a tour of the Brooklin boatyard set up, and we're on our way to see the premier boatyard in America. Pretty stoked. I'm sure people in Port Townsend would disagree with us, but we're gonna go see Brooklin, and you've never been there, right?
No, sir.
So it should be awesome. My buddy Daniel, who's also from Los Angeles, is the one that set everything up for us, and we'll be seeing him as well. So let's go check it out.
But yeah, so we never do the same thing twice. Every once in a while we'll build a boat twice, but it's not the same. I mean, we're a custom yard, so even someone says I want that same boat, it's not like a production yard. They say, well, I want a different interior. I don't want the settee. Can you make, it always they always become a little different. The deck, the ergonomics of the deck is different. The down below is a little different. So even on the boats we build over again.
Are they all wood? Or are they glass as well, or metal?
No metal. They're mostly co-molded, and we'll show you later. We do have another wooden carbon hybrid. Like this boat with the lifting keel here was looked like a wood boat inside with foam and carbon. All right. Outlier was another boateen boat, and she's a completely co-molded boat, but with a lot of carbon reinforcement on the chain plates around the keel.
Okay.
And upstairs we have a smaller, up in the other shed we have a 43-foot version, smaller, and that's the same thing, co-molded boat with a carbon and foam deck, and then a lot of carbon reinforcement on the keel and chain plates.
Wow, that's
so these carbon hybrids, which I don't think anybody else is doing.
That's pretty neat. Yeah, it's like definitely like old world versus new world. Like
it is.
What was that boat we saw yesterday?
I forget the name of it. It was a 76-footer that you guys built.
2007.
Sinfera.
Yep.
Yeah, she's an old Goshawk, that's what she was called. Yeah, they just got a new rig. Yeah, we built her. Yeah, and she had some carbon in her also in the laminate. I think she was wood, carbon, foam, glass. I think with some veneers in there.
When you guys are mixing the foam, is it strip plank, then foam, and then carbon?
And sometimes another layer of veneer, and then a wood skin on the outside. We've done it all. I think today we would go wood veneer, carbon, foam, carbon is probably what after what we've learned, And that's how Taroa was built.
Wow.
The problem with building a boat that way, the smoothest part's the inside.
Right.
Every time you put another layer on, it gets rougher and rougher.
Right.
Oh, wow.
So it takes a lot of work to fair the hull, because you can't fair carbon.
Right.
Carbon is the carbon. You don't. It's not like glass. You don't want to grind through it.
You have
So there's no high spots on carbon.
Right.
So you gotta. The only time you have the chance to fair the boat is the foam, and then the carbon on top of that. So it's a difficult way to build a boat. What it does save is all the tooling. You're not making molds and tools for everything. So there is a trade-off there.
Right.
Anyway, so that's.
And so, like, how many boats do you guys build a year, roughly?
Depending on the scale. If they're little ones, that are 10, 12,000 hours, we could build 3 or 4. If they're boats that are 30, 40,000 hours, 50,000 hour boats, then there's one.
Yeah.
You know what I mean?
Totally.
One small one. So it depends on the year. Basically, we put about 40,000 hours into the new build, and we put about 40,000 hours into our restoration and maintenance yard. Now, the maintenance yard maybe do small jobs, 1 or 2,000 hour jobs, restoration. If it's a big restoration, it comes into the new build side of the yard. Like we just did a big motor sailor, S&S motor sailor. It was 30,000 hours to rebuild this 65-footer. So then it becomes part of the new build yard.
Yeah. And that was an all teak hull, right?
And it is mahogany now. Built in City Island. But replanked the bottom, all new interior, all new systems, new deck. You know, so.
And then Daniel, how long did you work here?
Oh, just about 4 years. Yeah.
So, yeah. So, like I said, so you see the the restoration stuff we do, like in Tyser up here, the big houseboat, I guess you'd call it. Big Trumpy we did. She was 85 feet. We did her in 2000. Aphrodite, we got pictures of her upstairs. She was a big commuter from Long Island to New York, 76-foot go fast double torpedo stern. So we're all over the board, whatever comes in,
And like Regal View and Botein too.
Yeah,
That's like totally.
I know.
The front end.
And the thing is, I've fallen into the role of doing all the traditional work. I take that, and if it's a carbon job, I take that. I don't do anything in the middle anymore. I don't know how.
One extreme or the other.
I don't know how that happened over the years.
You've been around since me. Yeah,
86.
Since '86, and so you were here when the yard was really starting to push the envelope with the cold molded technology.
That was in the 90s. We started pushing it. Yeah.
So the boatyard was pretty instrumental in developing a lot of the technology used all over the world now for cold molded technology.
Yes. We stuck our foot out. We kept on pushing the limit. Steve did. Steve kept on taking these odd jobs. These hybrids and new ideas, and he'd push it each time. I think that's what he enjoyed, instead of just getting yourself comfortable in a little slot, and that's what you do. And I think that's a lot of the success of the yard, because we were able to jump out of our comfort zone. It's a gamble.
Yeah,
it worked,
doubt.
But it worked out, and we're still doing it to some degree.
Totally.
Yeah. The keel bolts are going to go through. Wow. We're not bad. We're going to don't know how to do carbon.
Holy smokes.
Yeah.
How many? This is not one foul swoop to laminate that, right?
No. It was a couple. Yeah, a couple different components put together.
That is bonkers.
Yeah, so.
And is there a timing that gets like a chemical bond in those guys? Or is it a mechanical bond in between certain layers?
Yes and no, depending on where we are. If it's a day or two, it's not a problem. We use all epoxy, West System epoxy,
Right.
ProSet, their line. They formulate this stuff just for us.
So there's like a longer kind of green window.
Sometimes depending. Yeah, we have a couple of different. We use. I don't like to have too many different epoxies in the shop because I have too many people. It only takes one person to mix their own.
To mix their own.
and that never works. It either goes up in flames or it never does anything. Yeah.
It's incredible.
And so is this.
3D printed titanium.
Well, the government's been doing it forever.
Wow.
So there's a lot of product, stainless steel, and this is 2205.
This is a lot
stainless
than the pad ice that I've been using.
Yeah. But this is and this is stainless, a 2205 or an Aquamet. It's dissimilar metals, so you don't get any galling.
Right.
So they don't weld themselves in. This is one that the threads were messed up on, so we never used.
Wow.
So.
That is bonkers.
You can see where it's printed, where it's not polished.
Yeah, it's amazing.
Yeah.
Yes. See that.
And do you guys do that on site, or there's a...
No. The company we used was a private company that did they did a lot of aerospace stuff, but then the government bought them, so they're hard to deal with now.
How do you manage having like the sort of differences in strength of the two, and what kind of math do you have to do to figure out how to balance the two so one thing doesn't break the other?
Yeah, so there are a lot of considerations that you wouldn't necessarily have to have in normal wood construction. For instance, you put wood and carbon together, and all of a sudden the wood is providing relatively small contribution to the strength of the part, but it's taking a lot of shear load. For instance,
Right.
Let's say you make a beam which is carbon, and then a big chunk of wood, and then carbon. The wood's seeing a lot more shear loading than it would in a standard wood laminate. So we kind of got to play with the numbers that way. The two materials play really well together, because they've got similar amounts of elongation to fracture.
Uh-huh.
So like if you put wood and fiberglass together, the fiberglass will stretch a lot more before it breaks than the wood will. So even though fiberglass is stronger, the wood's going to fail first.
Right.
But if you put wood and carbon together, they both stretch, roughly 2% before they fracture. And so they sort of, you're able to get, 80-90% of the strength out of both materials before there's any fracture.
And what's the rationale for the mixing?
It's just whatever material works better for that place. So
you're just-
carbon is heavy. Carbon is super, super heavy.
Mm-hmm.
The reason that carbon construction is lightweight is because you can use less of it
Right.
if you can use it in the right places. But if you were to just make a beam out of solid carbon, you'd have to come up with some, basically like steel profiles, like an I-beam or something like that to get something structurally efficient. But if you throw wood in the mix, you can have a beam like this,
Right.
where you've got a wood that's filler piece, but wood is a I'm going to use an untechnical term, structurally less dense.
Right.
There's less structure for the amount of volume it takes up. So this is, structurally speaking, an I-beam.
Right.
The carbon is several times as strong for the area.
Mm-hmm.
So if you imagine this all being one same material, you've got yay much material at the top, and then scaling the wood by the ratio of its strength, you've got yay much structural material in the middle. So this is a nice square looking piece. It looks super traditional, it's easy to build, all the rest. But structurally speaking and weight wise, it's an I-beam.
Right.
So
Makes total sense.
we can play with that, and then
And then what's the carbon element of that? Just the black strip there?
Yep, yeah, just this black strip right in here.
Mm-hmm.
Plana doesn't like it much.
Yeah, a little hard on the tools.
I've hit it before. It's a lot. Straight through the end of the knife.
Yeah. So it's a mixture of going after the look we're after, the production, fitting it into our production processes. The way we build our boats is not in a mold. And to
What's that?
Right.
build a carbon boat, you've got to have a mold
I
of
do,
some
yeah.
sort. And so we can integrate carbon into our hulls by integrating it into the wood construction. So we still have the wood and the buildability of wood, and that we can make a boat without building a full mold.
Right.
But we can get some of the advantages of carbon. And different projects, different sizes or complexity or shapes, it depends on. We do it different ways. For instance, the 47s, like the one on the wall up there, that's sailing away in the picture.
Right.
That one is a wood carbon hybrid where we made a strip planked hull in wood, sheathed it on the outside in carbon, flipped it over, and with no structure on the inside.
I don't think so,
Carbon
only
the
because
inside.
everything just
And
gets
so then
so
it's
full of dust.
a carbon sandwich construction,
Yeah.
but it's wood instead of foam or honeycomb for the core. So it ends up being a really lightweight, but still relatively easy to build construction.
I appreciate you thinking of us.
Yeah.
So, but sorry.
Whereas
about
other
that.
boats, we're doing a 5-skin cold molded laminate, or 5-layer, such as this. And this one we're mixing different densities of wood.
Okay.
Sure.
And then oftentimes, in this case, due to
Okay.
rating rules, we had e-glass on the outside, but oftentimes we use carbon on the outside,
Mm-hmm.
and that way we can use the carbon to its advantage to make this panel lighter, and then also strategically use some carbon reinforcement on the inside where needed, and that lets us have a homogeneous hull skin, because in wood construction, the whole hull skin basically has to be the same laminate.
Sure.
Whereas in composite construction, you're often adding extra reinforcement
Right.
in certain places, and so it lets us play that game where we're using a hull skin which is lighter, and so the hull skin is optimized for the lightweight areas of the hull, and then the carbon is used to reinforce it where we need more strength in the higher loaded areas. So we
Wow.
can play some games
So
like that.
cool.
Okay.
And you do all the math on it.
On many of the boats,
Anyway,
yeah.
give me a call anytime.
I do
All
some
right.
of it. We work with Pure Engineering, an engineering firm down in New Zealand.
Right.
They specialize in real extreme race boat carbon stuff. So in areas where we're getting a little more carbon heavy, like a carbon chain plate, we'll kick it over to them because I could engineer it, but it'd be twice as heavy because my
Right.
safety factors have to be a bit higher than theirs are. So,
Right.
So it's a combination.
It's so cool to hear about it.
Hey there, Blake.
All right, James.
James, how you doing, man?
YouTube channel, failed
partner off Center Harbor. Good partner off Center Harbor.
Oh,
You've
cool.
seen the videos
Mhm.
of stuff?
Yeah.
So anyway, he's running this project here.
And this is that motor vessel that we're looking at?
Well, he's actually got two of them going. So he's kind of keeping track of two different projects, keeping them all straight, keeping the parts straight.
Wow.
Two back to back.
Lot to remember.
A lot of those.
Yeah.
Will has worked with their computer operator, and every time we make this mold and set up, we refine it. It's better, it's better. So the guys, you get a guy right off the street.
It's called the Kennedy compound. Kennedy's ordered a boat. There wasn't enough room to have them built.
So, got this.
they built it.
You can't get off.
See, this is what Noah wants to. He wants to be able to paint like this.
It's a skill, and the painter here is doing great.
Yeah.
I spent of the 4 or 5 years I was here. I spent one year in the paint shop, and wasn't too happy about it at first.
Yeah.
But by the end of it, I realized how much I had learned and what I didn't know about fine finish painting.
Yeah. I mean,
a
it's
whole
like
skill set.
time with the gun in your hand. I would imagine has a lot to do with it, and good instruction, right?
Yeah,
Like-
yeah. But all the chemicals, like, and knowing how the environment works, like, you spray the whole room with clear coat before you start to make sure that you have this, like, you just get all the dust out of the air
Yeah.
that way. And
Wow.
just knowing that process. Yeah, it's
That
pretty.
is wild.
Finishing this.
Wow.
In the modern world.
Right? Wow. Like it already has the name on it.
Yeah, if you want to hop your shoes and go have a look.
When we moved in, it was the president coming to Ramsey.
Okay, at least have it on the side.
That's good. That's all I needed. Yeah, and when Jenny was here, we lived in Brandon and she stopped.
I like that you just said 15,000 hours is fast. That is. I mean, when it comes to that, building that from nothing, I guess it is. But in like today's standards of like everything having to be made, I guess that's why people come here.
Hope so. Yeah. Keel for it out here.
Two bolts. And then what do you bed that with?
100%. Absolutely.
Well, what we'll do is there's like 3 millimeters of tolerance up into the pocket. We'll dry fit it, make sure the keel's straight and in line with the rudder. We'll put the rudder in, and then we'll take it out and I'll put a thick epoxy. But the inside the pocket will all be waxed, so you can pop the keel off again. So that makes up the difference.
Wow.
Yeah, and we were debating whether to have the potting or the bog or the material on the head or in the pocket, and they said no, it's best if they ever change keels. That way, you always want that tolerance. Then you have to do the same process again.
Yeah.
Because they change keels on these boats all the time.
Really?
Yeah.
Now, why would they do that?
Just for performance, whatever they think they can get. They may go another foot deeper.
Different conditions.
Or maybe even storing the boat, huh? If it's that easy to interchange.
Yeah.
Wow.
So that's the next challenge, to get that in and out and make sure it comes out again. So that's what we're working on.
Keels, or is it Mars Keels?
That's Mars.
Is that a separate company that just...
It's in Canada, yeah. Yeah, that's just a steel bar. That's just a steel spar, they call it, down in there, bolted in, and then there's a carbon foil around it.
Huh.
Yeah.
And then what would the material be inside the bulb there?
That's lead.
Lead.
Wow. And then what you see, that goes down through is steel.
Wow.
Has through bolts to go this way through it?
No, it's bolted down through.
Okay, so they're bolted straight through.
Yeah.
Okay.
Yeah.
Wow.
And then there's a big pocket there they filled in now. And then once we weighed the keel and we weighed the boat and everything, then they adjusted the last little bit of lead just to get that micro adjustment.
For the balance, or?
Yeah. Yeah.
So that wraps us up on what you guys are doing at the moment. So thanks so much for having us. Really appreciate it. Thank you, Daniel, for organizing it.
Yeah, of course. Yeah, my pleasure.
And,
anytime.
Yeah, stoked to see it. Thanks.
All right.
If you enjoy the content on this channel and would like to contribute, you can consider joining the Patreon crew. Thanks for watching. Fair winds until next time.